Hi everyone, today I'm presenting my final project for computational photography, which is on image stylization by edge-aware processing. The specific problem we're looking at is how to stylize a given image. There are two types of stylization we're interested in. The first is cartoonization, which looks at removing the detailed texture while preserving the salient features, such as the edges. The second is to transform photorealistic images to have a more painting-like appearance. As a bit of background, bilateral filtering is a straightforward technique for edge-aware processing. However, as it operates in 5D space, it is very inefficient to be computed in a brute force fashion. Therefore, in this work, we use this domain transform technique, which first transforms the image to a lower dimensional domain while preserving the edge information. Then perform the filtering in the lower dimensional domain before transforming it back to the original domain. Doing so iteratively, we can achieve similar effects as the vanilla bilateral filtering, but with some more efficiency. This shows an example from the original paper on domain transform processing. On the left is the original image, while in the middle shows the smooth image using the domain transform edge-aware processing with the parameters recommended from the original paper. We can see that the face of the statue is a lot more smoother and the wrinkles on the golden ball are removed. On the right shows the edges detected from the smooth image by first computing the gradient magnitude and then passing through a dilation process to thicken the edges, and finally applying a Gaussian blur to soften the edges. It is shown that all major edges, such as the boundary of statue's clothes and the boundary of the ball, are extracted, along with some visible wrinkles on his clothes. We then integrate the smooth image with the edges by brightening the smooth image first, and then taking the minimum intensity per pixel for both images. This leads to the image on the right, where the details such as the surface of the ball and the face are removed, while the edges are emphasized. We can also apply the same pipeline to other photos to generate a more cartoon-like feeling by integrating the edges with the edge-aware smooth image. In this example, the boundaries of the fries are highlighted while the textures on the burger is abbreviated away. Leveraging the joint filtering, we can apply style transfer. This example shows that if we jointly filter the original image with an auxiliary image that imitates brush strokes, we can get a style transferred image on the right. The idea is that the auxiliary brush image will provide the brushstroke-like boundaries, while the original image provides the color information. In this example, the resulting image picks up the vertical brush-like lines while it's still recognizable as a burger. It feels like looking at a burger through a raining glass window. This looks better when we have brushstrokes that are consistent with the image itself. Here are two examples of different types of brushstrokes with different entities. On the top row shows an oil paintbrush on the entire image, while on the bottom row shows watercolor stroke only on the burger. This shows the flexibility of this approach in that the user can choose whatever types of brushstroke they wanted and whether they want to highlight the object while blurring the entire background or they want to apply style transfer on the entire image. Further experiment on sigma R shows that the larger the variance set, the more coarse the brushstrokes are. The details such as the sesame seed on the burger are completely removed when sigma is set to 1.5 as shown on the right. When comparing our method with an off-the-shelf deep learning model on style transfer, it is shown that ours have a more realistic brush-like feeling compared to the other, and the baseline only applies certain texture to the image without actually giving it a paint-like appearance. Additionally, the machine learning model does not support arbitrary edits or arbitrary strokes. As a summary, in this work, I re-implemented domain-transformed edge-aware processing for image stylization. I also explored how to use joint filtering for style transfer and give image a more painting-like feeling. And lastly, I made all of the stroke templates and the code for pipeline publicly available. And that is all for my project. Thanks for your time.